Virtualization, computer science and hardware manufacturing has had a long history with it. On the mainframe, they created a operating system which allowed you to run virtual machines on IBM 360 and 370 class mainframes, VM/CMS. It was a competitor to IBM's proprietary operating system for a time. And then things kind of went away for a while, but virtualization in software or hardware has always been there. Why do we have virtualization and what's it used for? Well, in security, there are great reasons to have it. You can isolate things that might be harmful, right? You can do reverse engineering. You can also try to create a secure bubble for people. And so this is done in a lot of corporations. When you access, internal corporate data, they try to keep you in some type of virtualized environment. The virtualization can be either at the server side or at the client side. You could run a virtual machine on your home machine with a secure bubble, and everything you do to access that corporation has to be done inside that virtual machine. And that little virtual bubble then gets cleaned up or thrown away at the end of your session. Some of the VPN manufacturers provide these. Or you can actually run a virtual operating system at the remote end in the data center on a server. Mostly today, when people talk about virtualization, they're talking about server virtualization, right? Talking about taking physical servers that are taking up space and heat and everything else, power in your machine room, and turning them into virtual servers where you've got a whole bunch of these virtual machines running on blades that are crammed into servers in the machine room. But there are people that virtualize clients as well. You can even have a virtualized client of your XP desktop, but you run it back in the data center. And when you want to use your XP desktop machine, you do what? You fire up your thin client, it could be a WISE terminal or something else, and you connect to your virtual machine and it shows up on your screen, right? Even though it's protected and locked up somewhere down the data center. So we'll talk about the different virtual machine architectures and software platforms, a bit about VMware and its particular architecture. We'll look at some real life scenarios in virtual machines, and then talk about snapshots, thin apps, server consolidation, etc. Right? These are the two big virtual machines that are on the market today, right? VMware, which is really the original one for PC architectures and Windows, and then Microsoft, which is a bit of a latecomer, but it's going gangbusters and taking away market share from VMware. So Microsoft is now seriously pushing its own virtual machine architecture, and it has quite a number of data centers which we've converted and running Microsoft's virtual machines as well. There are other virtual machine vendors out there as well. These are just some of the things that you can do, right? Security testing, you can use them for classrooms like in here, where you might run programs that you're going to destroy the operating system. Well, as long as they destroy a virtual operating system, we don't care. We can just clone you a new version of the VM and give it to you and say, here, right? We don't have to actually go and re-image the whole machine. Great for help desk support, emulating, hardware in software, and flexibility at low cost. You can also do things like build appliances for people and say, here, have this appliance to run this software. You don't have to actually go and install the software or do any of that stuff. You just boot up this machine and it'll run for you. Here's your traditional platform, right? Physical box. You have to install the operating system. You have to install the applications. You have to take care of the hardware and software. In a virtual architecture, you get many benefits, right? You can run multiple operating systems and separate machines on one box, right? You can also shut down the machines easily, start them back up again. If you no longer need them, you can just get rid of them. You don't have to get rid of some physical box somewhere, right? This is VMware. The neat thing is if you have farms of these and you keep them in separate, physically distant data centers, you can start migrating machines. If you've got some kind of natural disaster going on in one data center, you can just pick up those virtual machines, say, okay, suspend, write yourself out to disk. Okay, now I pick up that virtual machine, I drop it on some other virtual machine server in another location, like let's say in San Diego or whatever. And now all of a sudden I've migrated all my machines over to this other geographical location. We do that. We actually have 4 data centers, and typically we'll load balance and we'll move some of the virtual machines to the other data center, not always during the day. We see VMware Virtual Server, also Parallels. Parallels is big in the Mac OS marketplace. I have both Parallels and VMware on my Mac. There's some other ones that are out there as well. So VirtualBox, which has been acquired by Oracle of all people. When they got Sun, they actually got VirtualBox. And Zen as well. This is the VMware architecture. So it takes a traditional Intel 86 architecture machine, and it emulates it in software. But it looks like it has a CPU, and it actually has a Hertz. It has memory, including read-only memory that are part of the virtual machine. It has network interface cards that are virtual, but they look like standard Ethernet hardware, their own type. They used to emulate like 3Com cards and things, and they had standard disk controllers that emulated, fairly stock off-the-shelf disk drives. They also will often have CD-ROMs, floppy drives. They have pass-through USB, so you can actually take physical USB devices and have them pass through and appear inside one or more of the virtual machines. Right? So each virtual machine has its own drivers. Those drivers then communicate with the software layer in ESX and say, okay, I want to go to the network. Now the networks can be either just purely local between the virtual machines and their host OS. They may not have any networking at all, or they can have either bridged or NATed. If they have bridged, then they get to share the Ethernet device driver, but they get their own, for example, IP addresses and MAC addresses, or they can be NATed, in which case all the traffic from all the virtual machines coming out the Ethernet card from that machine appear to come from the same IP address. But internally, the traffic goes back to different virtual machines. Right? So there's a lot of different things you can do with the networking inside the virtual machine. Here's another thing you can do. You can actually set up some standardized tests, like the tests we take at the end of this course, etc. The old way, if you were using a Pearson view, which was their authorized test center software, you had to have 3 physical machines to set up the test in a location, right? 1 running server 2003 and then 2 XP boxes. Not what you'd call a mobile testing. The new way, you just set up 1 physical machine and it has 3 VMs in it. You can also take snapshots, and you can take several a day. Snapshots allow you to roll that virtual machine back to another point in time, right? So if you trash your virtual machine, you do a software install and it goes wrong, goes bad, really bad, you just say, what? I'll go back to my checkpoint, right? My last checkpoint, when I know I was known good, and I can roll back. If I notice the problem is even further back, then I might have to roll back to a previous checkpoint here. The neat thing about the VMware Snapshot Manager is that you can actually click on one of these, select it, look at what the screen looks like, and your description, and say, no, that's not the one I want, and then go back further or forward. VMware has a number of different virtualization technologies, one of which is ThinApp, where they take an application and they virtualize it. Everything looks like the application. It even has its own installer. But when you install the app, what it does is it puts in this little thin layer here, which then calls some remote system where the application is actually being hosted and you're running the application over the network. But it's all transparent to the user. They don't really know that they're using a VMware application. Very similar. Citrix has very similar things as well. Okay. Yep.
So, is it possible for someone to sort of spoof an application on your machine?
That possibility could exist if somebody gave you an installer. So you think you're actually installing the application, and it looks just like the application because you have all the front end, graphics of the application. But they could then, by using ThinApp, have it talk to their server somewhere remotely over the internet even, where they're looking at all the data. They think they're running some local app like Word, right? Because they've ThinApped it. But they only really have the graphical user interface part of Word, and you're running the guts of Word on your machine, right? Back on the server. It'd be a little hard to do that because Word expects to open up the files locally and then write to the files locally or whatever. But yes, you could do very similar things to that. Mm-hmm. They could. They could put a little game application, for example. People think they've downloaded some game and they're playing along with it, but it's actually sending data back to the remote machine. Now, this is just the marketing example of server consolidation. This is really the big financial win for a lot of companies. This was the availability that I talked about before. You can actually have virtual machines set up in fault tolerance mode, so if you lose one of your virtual servers, everything fails over to the other server hosting other VMs. And these could be in different machine rooms, right? So here we've got multiple virtual machines all acting in failover mode. So it's seamless. people don't even notice that one of the virtual machines has failed, which is performing the service. Everything just falls over to the other one. And these are just some of the emerging standards in the VM world, right? We have standards in here for IEEE 802.1qbg and 1qbh, specifying routing for virtual machines. You'll notice that virtual machines and servers also have virtual switches because they have a virtual network inside them for all the virtual machines to communicate with, and a way for that network to then go out to the physical network if you need. We have virtual data centers existing in the cloud, virtual switches which are an extension of real switches in the real world, and a virtual Ethernet port aggregation where you can have multiple virtual machines share the same Ethernet port, or they can have their own ports, or you can take multiple high-speed ports and put them together and have them used by the virtual machines. Right? And somebody's forecast that over half of data center workloads will now be handled by virtual machines in the year 2012. But we've seen some control of the network being handed over to people who are system administrators of these virtual machines, and what you really want is for control to stay with your networking staff, right? You can download the VM player for free. Your machines actually have VM Workstation on them. I have VM Player on here, and you can get a number of virtual machine appliances.